talking to the field. And,
Yeah.
so,
And we won't have that problem anymore.
Okay, this was a much larger network. So we had 13 new points. We had 3 benchmarks that we included into it. We were doing pair points. One of the pairs though shared a common point. So 3 points acted as 2 pair points. So we had a pair point. These two, this pair point shared this point. We had a pair point over here, pair point over here, and a pair point over here. And this was for river profiles. The river basically ran, I want to say something like that. Okay, but we constrained it. We had OPUS RS at 2 points. So when we get to the adjustment, I think one of them was 110 and one of them was here. That's why they were radiating out of there. So we had 6 azimuth pairs, 13, 2 pairs shared a point. Static, all these vectors were static GPS vectors. We leveled between the azimuth pairs. So we leveled from here to here and back. We leveled from here through here and back. Leveled through here, leveled through here, leveled through here. So we had to include the leveling in the least squares adjustment, which presented its own problems. We did a single least squares adjustment with 4 types of observations. We had OPUS RS, static, total station, and leveling. So because we shot the distances between each pair point, and in this case, we turned the angle. The specs on this were really loose. Corps of Engineers really couldn't tell us, and the project manager from who we were working for as a sub. So I had to go through the engineering, the COE engineering manuals and justify what I was doing. So they said OPUS is ideal for establishing accurate horizontal control relative to the NSR. So I used OPUS. They said second order. They didn't say what kind of class. So I just assumed second order class 2. So you have a baseline, a base error of 2 centimeters, 66,000 at 20 parts per million. You set that in StarNet. Your options. Yeah, 66,000 and 95% confidence interval for 20 parts per million, and I did it for all connections. And this will come into play later on because I wasn't quite able on some of the shorter baselines to get my 20 parts per million. But with the combination of the total station thrown in there, I was able to get everything below the when I did my connections and check them out this way. So that's how I'm going to argue that if I'm in my control report. Okay, so let's start running the adjustment. I have my OPUS RS on 0.102. And I had 1, 2, 3, 4 shots on there. Okay.
Uh-oh. It's the
There we go.
Come on, girl.
GOA again.
Oh, okay. Looking for the GeoID file on my computer at home, or back home, yeah. Okay. So we have 4 OPUS on 102. None of these look out of line. We have the OPUS factor, we have error factor of 2.057. 2.057. They come out for 1. No outliers of flag. Move on to point number 110.
That's a nice error factor. I think we should plug that one in.
Yep. Happens occasionally. And
144.
we got something went wrong on that particular set.
Somebody picked up the base and moved it.
So we could safely say that that's an outlier.
Sun came out and it's like, just like that.
So rather than go to line 13, it brings us right to the bad one. And normally the files don't come in and say this is an outlier.
That'd be pretty cool.
I'd take that one out. And I don't know what happened there.
Thinking of Amish family. Came out and moved it.
Could be like when I did the RDM1 scan and the surveyor for the construction company decided he really needed to level off the point my base was set up on, so they picked it up and moved it 2 feet and just.
But
Did you put it back afterwards? No, just left it 2 feet off, so.
But somebody was supposed to be attending that point when the receiver was there, so nobody ever told me that it got moved, so. And actually, I think the static observations from their work, it's just. Stuff happens, yeah.
On the left.
So in that case, now we only have 3 at that point, but now the residuals are all much more reasonable. And so we would run it with
You're looking at the residuals. Is there a rule of thumb you would use, like you use, or is it kind of just job specific for what you would consider like having a residual out?
For the order thing with the 66,000s.
Because that one was 1,300.
That was, I guess, my question also. If like an error factor, is there a number that you're like?
no, there's no number, because we talked about the error factor depends upon the residuals and the estimate of the errors in the observations. So if those error estimates are way optimistic, that number's going to go, that error factor is going to go way higher. So you really have to look at the residuals. Now, 3 centimeters, basically a 10th for your vertical. I'll put, I'm not going to reject the 1200s, but so that's basically that. And then like 2 centimeters, 1 centimeter, 2 centimeters, like 500-600 for your northing and easting or so.
Okay.
But it's also going to depend upon what you're doing.
Yeah,
absolutely.
If you're doing higher order control, then you're going to want to make that maybe tighter. And you're also going to QC your vectors actually before you bring them into your adjustment. And we'll look at that. We're going to do we're going to bring everything through like your infinity and we'll get it up to the point where we would do the adjustment. We'll do all the QC and everything. And actually, we're gonna do it in here too. We took that out. Now, so this would all be done outside, this could all be done before you ever opened up, did any kind of baseline processing. If we run these two together, you're gonna get a 1 because it's just the way we set it up. Okay, so now we have our constraints done. We have 2 points on the ground with error estimates for those points based on, in one case, 4 OPUS observations, and another case 3. We had 4, but we rejected 1 of them. So this is the processing that we did. This is like your Infinity for that same project. So after we've done the baseline processing, and we'll do an example of processing, I just want to show what we would do is we would have all these GPS vectors. And we would sort this back in. So we did this originally on August 10th and 11th. So if you're looking, you see this stuff from the 21st. We ended up having to go back out and do some other work. But these would be processed. You would highlight this and you would do a save as. And you could save this as a CSV. And what that would look like is, and you would bring this into Excel in order to do your QC. So normally what I'll do is I'll just bring in all my vectors. And so I leave this tab. So I can always go back if I need to. And I will, so you have your from, your to, your dx, dy, dz, your slope distance. I have to I put this in myself, manually put it in based on the times or the sessions. The session is 3 digits for the day of the year, and then a letter for each session. So we had 1, 2, 3 baselines per session. So we had 4 receivers running. You can only do the number of independent sessions you can have. The number of independent baselines per session is n-1, n being the number of receivers running. So you could create up to n times n-1 divided by 2 baselines per session, but only n-1 will be independent. And when you have more than 2 receivers, or well, actually when you have more than 3 receivers running, you can't close a loop in a single session. If you close a loop in a single session, you're using a dependent vector. And okay, so I have all my vectors here. And so what I'll do is I'll just copy this. And I'll start pulling out my vectors. So I know to my baselines, to my benchmarks, I know, so like 104 to 103. I'll look for my next 104 to 103 when it's repeated here, right over here. And I cut them and I cut and paste rather than copy and paste. When this is empty up here, then I know I've used everything I have. And I'll just keep doing that. I'll form them. So I come up and I format it something like this. So from to these I have no repeats for. These I have no repeats for. And so I know, I'm looking at, having looked at what my network is supposed to look like. I know which ones have repeats and I know which ones don't have repeats. So I make sure I account for all my repeats. And then, so from 104 to 103, I just subtract. Now, for two baselines, you could just take the top one minus take the absolute value of the differences. And that works fine. But when you have more than two repeat baselines, what you want to do is you want to know what the difference is between the maximum and the minimum. Okay, so what I'll do is I'll do the max of those three minus the minimum of those three. And that works for two vectors also. So I just use that same formula. And the advantage of that is when you have one that doesn't repeat, well, it doesn't apply in this case because you have the only ones that don't repeat are the ones with two. But if one of these didn't repeat, I can then just start going, okay, that doesn't help me. Okay, so I can take out one or the other.
Right.
And so I'll check them to see if they repeat, make sure that they repeat within spec. So you take the difference between them. And then this number here, the PPM, is this number up here divided by the shortest one of these. It really doesn't make that much of a difference. And then in order to be able to copy that in Excel, putting a $ in front of either the column or the row makes that absolute. If I didn't put that $ in before the F, it would start trying to, it would use a relative distance and it would move over the column. So, so once you do one of these, I can just copy and paste. So I get these differences and I just copy and paste, Control C. I can paste that over to here, and so I got my PPMs. And I wanted to try to get 20 ppm. And on these three baselines, and you'll notice these are all pair points, 101 to 102, 19 to 110, and 111 to 112. These are short baselines, 885 feet, 817, and this is 1,000 feet. Now, 18 thousandths is really not that bad, but it's a short baseline. That's why I was talking about. Yeah. And even with the total station, you should be able to repeat that, but you'll see that sometimes even with the total station. 500s, 500s there is kind of pushing it. What I'll do in that case is I'll go back into Infinity and I'll try to process different ways in order to maybe try to knock that out. But Infinity, the baseline processing is pretty good. And it's in order to get, so in 885 feet, 20 parts per million, it's, yeah, 17 thousandths. And I'm going to try to have to teach from 500s to 17 thousandths.
Not bad.
That's a lot to try to get out. 18 thousandths actually. So it would be, I mean, I tried. I just wasn't able to do it. And we ended up having to go back out again. And here you see where now I have three and I could play with which one I wanted to take out. So just taking that one out help? No. Just taking that one out help? It's still over 20 parts per million. Taking this one out, 27 parts per million. So I never was able to get here. I was able to get it to 22 parts per million. Able to get it to, this one I was never able to get it really good. Once again, these are, well, that's 1,000 feet.
Position for.
I think it's a factor of just the short baseline. But I was combining this with total station measurements too. And sometimes you could, depending on how much time you have and everything, you could do an adjustment with just the GPS and the total station and try to tease out which is the best baseline also. Right. But there's a limit to how much you can figure out sometimes. So this was after we had to go back out and re-observe.
When was the last time we did baseline processing for a project up here? Never.
This?
Yeah.
I've never seen this before.
It really is like a usually.
I've never used it.
We can do the same thing like TBC and you were even saying magnet, right?
I would never use that.
I didn't put
Is there an
it
option
in
for Carlson for this? Will this import
I don't
Carlson
think it
data?
is.
Yes,
Like, okay.
yes, it will. You could import, I mean, we were talking about this a little bit yesterday. I know you have TBC up here. The Newark office is was considering buying Carlson's processor. I mean, we're one company, we should be using.
Yeah.
And because if you want to do some load sharing or whatever, work sharing, or you were to call us up and say, hey, I'm having a problem with this baseline, but I'm doing it in TBC, I'm not gonna be able to help you.
Also, I know like we have TBC licenses, but if we start using that for baseline processing, like you better be ready to be thrown out of TBC at random points during your process, because yeah, if like we can't get a model to a client on site because somebody's in TBC processing baseline, Wilson's gonna flip the shit.
Yeah, something similar happens here in Infinity. We only have one Infinity license, but I know we're in the process of processing at least one more.
Gotcha.
Okay, so more than once I've tried to go into Infinity and not been able to. And we have I think a control processing email group, so you just send it out, you know, I need a license, you know, and then somebody hopefully will be able to give it up. I've used TGO, I've used TBC, and I've used Infinity. I mean, the Infinity processor is a good processor. I can't say anything bad about it. I don't like necessarily the clunky nature of Infinity. Some of the, I don't know why they don't use the standard Windows interface. Some things work when you type in the file or the directory number, and it goes right to it. Sometimes it doesn't, and I'm not sure why. But it's a good processor. It would be really hard. I mean, I've done a lot of baseline processing. It'd be really hard to tease out from 500s to 18,000s.
Yeah. Can't make them out of be what it's not.
Yeah, mostly what you would do is you would try to raise the processing mass. You might try to take out individual satellites. I would try to take out entire constellations before I would try to take out individual satellites. I've had baselines processed I processed them with GPS, GLONASS, and Galileo, and got a bad solution to take out the Galileo, and all of a sudden it works. And that's not a judgment on Galileo, because Galileo is a good system. Just for some reason, randomly, that didn't work. So you can sometimes get them to work better, but other times you can't. I've actually, when I'm trying to tease out just a thousandth or two in order to get that number, and the difference between 20 parts per million and 20.1 parts per million is not significant. But somebody wants to see that 20 and not 20.1. Sometimes switching the direction of the processing will actually get you that little bit. And that's because of the way the processing is set up. So sometimes that'll work. In this case, we went back out and re-observed, and you could see I was never able to get it down entirely to 20. what I'll do is now, you'll see here, I said flag for process, flag for, in the LSQ. So now I'm paying special attention to these three vectors when I'm putting it in the least squares adjustment.
So this is more just raw coming from the GPS. It's not.
It's exactly, there's nothing, no adjustment. This is not an adjustment. This is just, what do I have for my raw data? It's kind of like when you go out and you measure a distance with your total station. Does it repeat?
Right. I think it actually exports this relatively easily. Holy shit, it's good
That's
for
what I'm
something.
saying.
Top Gun magnet software is the clunkiest motherfucker you've ever have used, but
When I was using it for Sanborn, I was noticing shit like that.
yeah.
It seems like that would be really easy for that.
So this is, so I don't really, at this point, I haven't rejected them. I'm flagging them for looking at it in the least squares adjustment. So then now at this point, I've gone back out and re-observed. So I would highlight all of these. And then I would go to export and then selection. And then I would use like a ski, ski ASCII, and that creates a file that could be imported into StarNet. And we'll do that here actually, and you want to make sure, this has burned me in the past, you want to make sure that this says Cartesian, and that would be for the Earth-centered, Earth-fixed Cartesian type coordinates. Okay. So now I'm back in StarNet. I've imported it down. Like a ski, I would do input GPS data. It would be Leica. I would select my input files. Now the exported data, and there were my ski files. I would select those. And it would create the GPS files. And then in this case, I separated out from that file. I would get one big GPS file, one DAT file. I separated out the file, the vectors that didn't repeat, and that was just a cut and paste operation. So I could pay special attention to them. And here I kind of broke my own rule. I didn't set up a separate file for my minimum constraints.
Yeah.
So I have to remember later on to comment this out when I'm combining everything in.
Yeah.
That's why it's nice to set up a separate one and you just unclick it.
Yeah.
So here you'll see it's a little clunky. I can create the file. I came over here to new file. Minimum constraints. I'll move that up. So those are my minimum constraints for just the GP, you know, when I'm doing a minimally constrained adjustment of my GPS vectors. Like conventional. But now I'm gonna use, once again, it doesn't matter which constraint I use. My GPS. And these are the ones that didn't repeat, so they get special attention. And make sure. And it doesn't come in with, this is an outlier. So I would run that. And I got error factor of 17. Now I've got a lot of GPS vectors. I've actually have, I go to my, if you click, you can either scroll down here looking for what you're looking for, or you can, if you click up here, it brings you up to a little menu and you can go right to your statistical summary. So I've got 57 degrees of freedom. I got a lot of data going on in here. So here, then there's old GP. Now you could try to scroll through here and look at your residuals, and you see a lot of vectors are flagged as outliers. Or you can come right down to here and you can see, okay, they got 2/10 floating around right there. You got 1600ths. Those two definitely over the 10. That one's an outlier also. They're both in file 3, which is the file that of GPS vectors that didn't repeat. If I double click on here, comes to the one that I flagged, that was flagged, one of the ones that was flagged as an outlier. So and now I'll highlight that. Take it out. And then I'll put a note in. I wouldn't say this, other than session 20, what section did not repeat, removed for high residuals.
Well, did not repeat, you made it in the field, we didn't reobserve that baseline, right?
Say again?
You're saying we just didn't reobserve that baseline in the field?
We did, that was one of the ones that we had to reobserve. Those three didn't repeat. I couldn't get them by reprocessing. I couldn't get them to repeat. So we ended up going back out in the field. Even after going out in the field, I couldn't get 2 that repeated within 20. So I don't automatically reject them right away. I just, yeah, they get special attention in the least squares adjustment. So I'm looking for those ones, you know. And then this one. I can rerun it. And then out of the 3 for 101, 102, so if I come back down here now. I knew 101, 102, I couldn't get to repeat, so just out of principle, I took out the, I took out the worst one, not necessarily the one that had the worst residual, but the worst one for the repeating. I just took that one out. Yeah, this one here, session did not. This is the outlier removed because of the worst repeat. When I took the different combinations of the 3, that one was the gave me the worst overall result. Process it again. And I get a relatively high error factor, 15.593. If I start looking at my residuals.
pretty good.
Nothing's remarkably bad. And once again, this is an example of why, I don't put a limit on this number. I've got, some people, people ask me always, yeah, so 10 is too big. Yeah, and it's a combination of two different things, so you have to, this one, the baseline processing was just very, very optimistic.
Right.
So.
Thinking back to one I did last year where I was just trying to get a low opus factor, and I kind of feel stupid about that right about now.
Yeah,
Like I was just sitting there turning them on and off to try and get a lower opus factor because I thought that was important. Apparently it wasn't.
Yeah, no, you see. I mean, yeah, we kicked one out here because it was obviously bad.
Yeah.
But if they're all agreeing with each other.
Yeah, this was like 4 versus 5, so I mean, it wasn't that big of a difference, but I spent quite a bit of time looking at that, so.
Yeah, I remember Locke, he would always say like around 8 opus factor, that's when you need to think about throwing one out. But it was really, then we started bringing in the actual opus static coordinates into a Excel spreadsheet and seeing the differences between them. There was like, these are fine.
Yeah. Oh, and you saw that, but you could just see that right by looking at the
Exactly, we didn't
residuals.
even know that existed.
Yeah, I had no idea.
Residual sheet.
Because that's the same thing, right? Basically.
Yeah.
A lot easier than inputting it yourself.
So,
Better.
Did you bring in every single baseline that from your spreadsheet, even the ones you knew were bad?
Yes,
Okay.
yeah, and that's the ones that I knew, I didn't know they were bad, I knew that they needed,
That they didn't fit with each other.
they didn't fit with each other. And so they got put in, segregated out,
Okay.
just to make it easier to look at. So I didn't have
Yeah.
to look through all those baselines.
Okay.
And then here's the advantage of, if I didn't just take those, like these minimal constraints out, I would have to go through and highlight them, but now I just unclick it. And how does my opus and my GPS all work together? And it works together remarkably well. So now I've got an adjustment with, go to my statistical summary. There we go, sorry. So I've got 21, so I got 7 Opus RS, 3 and 4 on two different points. And I've got, is that 87? I got 87, so we divide that by 3, that's how many GPS vectors are in there.
Okay.
And you've got a degree of freedom, you got 66 degrees of freedom, and about as close to 1 as you can get.
Yeah, okay.
And this is how much it changed from the Opus solutions, very, very little. At this point, I could add in my total station data. So from 101, so I'm 10, let me just refamiliarize myself with this quickly. For 101 and 102, we got distances measured. 103, 104, 105, we got distances and an angle, and then just distances between the others. But this also includes, okay, so this is the angle between the one that we have, and so that includes the distance. This is a side shot to one of the reference points. These are more size. So this distance from 101 to 102, and it ties to the references. the distance from 102, we measured in both directions, 102 to 101, 103 to 104, 104 to 103, 5 to 4, 12 to 11, 11 to 12, 6 to 7, 7 to 6. And then we actually, I think if I remember right, we had to send it back out to turn that angle. So I include now the conventional measurements, the total station measurements. And so now this passes the chi-square test. The distances, the angles, well, there's only one angle involved in there. You still have your 7 OPUS RS. You got 12 different distances. And your GPS, and this passes. So that's now combining the OPUS RS, the GPS, and the total station, which is what we've done basically up to this point on much simpler examples. But we also did leveling. We did leveling between these two, between these 3, these 2, these 2, and these 2. In the past, when we've done leveling, we haven't combined them into one. So now, these are the minimal constraints for our leveling. And this is our actual leveling. Now, in this case, they started at 101, went to 102, and went back to 101. They called 101 101A. It's the same point. So in order to take care of that, we talked about this yesterday. We have Starnet has what's called an alias. So you tell it dot alias suffix. So anytime it sees a suffix of A, it's just going to ignore that A. And so 101A is the same as 101.
Those are probably the little tricks and stuff I think that Jolly wasn't using, because when he showed me this stuff, he was like, you know, manually going through there and
removing all the A's.
yeah.
Okay.
So I was like, let's just do find and replace, and we do it that way. But that seems way easier.
Yeah, it's way easier. And if you wanted to check the closure yourself, you can take that A out.
Yeah.
And then you'll say 101 and 101A will be 2 different points, and you can compare the elevations. Okay, but once again, before you adjust your leveling, you should QC it. And QC leveling. So our internal leveling, I use that same process. We could do it, but so 101 to 102, back to 101. We had 8 thousandths. This is what we're allowed.
Yeah.
103 back to 104, 105, 104A, which is the same as 104. So actually, you could check this loop also. But those two you could see are, and so there you had 9 10 thousandths. Here you had 111 to 112, you had 18 thousandths, 106, 107, 14 thousandths, 24 thousandths. That's the high one. And you should, and we discussed it, you guys are using your turtles and your turning pins and everything, and with a digital level, this is what you should expect. If you know, especially if you're balancing your force like exactly. But just keep these numbers in mind. So I'm going to turn off all of these. Actually, if I click that.
Oh, no.
Okay, it's just bogged down. Yeah, okay. So I can turn them all off at once. So these are my minimal constraints for my leveling. Now, it really doesn't matter what these numbers are once again. And I have loops in here. Now, just to do on this alias again. These are all the different alias types you could do. You can alias name. I use this alias name for what I'm doing when we do ties into NGS benchmarks. Some using the crews, they'll use the PID number. I prefer to use the designation. So I could just put that alias name, and A21 is the same as KU 1234. You got the prefix instead of a suffix.
Additive number, so you can do like 100 and 110.
I think so, yes. I've never really used that one. We've always used the suffix. So and now options.
The additive number might be good, because I know that top count level somewhere on the translation, if you have letters in your numbers, it kicks them out and makes them all 9999.
Yeah, it counts down from there. It's really annoying.
It keeps them all 9.
Oh, it does really?
Yeah, all of them are
That could be
99.
difficult.
You gotta go through the.
If you don't have field notes, you're screwed.
Yeah, because your turning points have to be actual.
That's why you just tell them not to use fucking letters. But
But here's where we set the second order class 2 setting. So this is how it weights the leveling. Now, take this out. Comes into effect in a moment. Oh, because I left that in there. Oh, okay. When you see something like this, it thinks it's doing a 3D adjustment, but it only has leveling, so it has no way to create a coordinate. So just switch that to leveling. A lot of times I'll do my leveling separate, and we saw that before. Because we're going to include this in here, I just left it in here.
It'd be nice to be able to do them all.
So we're way, way, way better than what we expected. So 0.084. Now, so, okay, my leveling I know is good. Look at my residuals. I mean, my residuals are 4,000s, 4,000, or 10,000s, 14,000s. So now I'm going to combine everything into one adjustment. Now, I don't want my minimum constraints in there. That's the nice beauty of being able to click that out. I don't want my elevation minimum constraint. If you leave them in there accidentally.
So is it still just doing leveling right now?
Excuse me?
It does do it. You don't have to toggle back.
Right now, it's.
Oh, you know what? You're right. I'm sorry.
the 3D.
Yeah, I didn't.
Oh, no.
Okay.
Yeah, because okay.
Options. I gotta go back to project and make it to a 3D adjustment. Yeah. That's the disadvantage of leaving it. But so now if I accidentally left one of my constraints in there that I didn't want to do before. Yeah.
Wow, sheesh.
Because it's holding those zeros.
It's trying to hold the
constraints
elevations
for
at 0.
For every single instance of that point. Yeah,
So
you can see that being an issue.
when you see that happen, yeah, don't panic. You just click up. When it gets that bad, it's usually something you did.
Instantly giving fly.
It even gives you a warning saying that.
I guess that's
zero.
actually like a good safety net for making sure that you, like if you use 0, to make sure that you don't have them click on with like a slightly off elevation.
The general rule is if you're gonna be wrong, be really wrong.
Really wrong, yeah.
Yeah.
When you use north as your resident, pretty close to the in the field.
And the same thing would happen, I mean, actually to a lesser degree, it would happen over here, because those are numbers that are realistic,
Mhm.
Right.
and that actually passed.
That's what I was thinking.
Dangerous.
So with that said, this passed, but let's look at our residuals. Find our summit.
Should tell those you.
differential leveling. Look at what our residuals are. We got 14 thousandths. We got, we got 14 thousandths. We got 200ths. It's not in line with what our leveling, what we expected our leveling to be.
Because it's too low or
It's too high, way too high. I mean, we were closing in the 10 thousandths range,
Yeah.
but now it's getting residuals. So that the GPS and the total station are exerting more influence on this adjustment than the leveling is. And if you look at the PowerPoint,
the level weight.
so here, it's 14 thousandths. This is the when we did the standalone leveling, our worst residual was 14 10 thousandths. But if we look at the adjustment itself, and that was 104 to 103. There it's getting 10 times more.
Yeah.
So so this is not what we would expect. When we do our leveling, and that's because this is the how we were propagating our errors, how we were telling it that we were only expecting to be able to do 0.035 times the square root of the number of the miles, and we were doing much better than that. That was reflected by the low error factor that we had. And when we combined it into that, and there's where we saw that 13,000, almost 10 times larger. And our leveling data, okay, so in here, this number is way low, so it was done better than what we thought it was, what we thought it would be. So in order to fix that, we come over here to our leveling. So we'll toggle everything off again. There's our minimal constraints. Now there's two ways to do this. There's this inline command called lwait. You set that to 1. And that overrides this over here. So this is now ignored.
We want to change it to leveling.
You're right.
Sure.
And then by changing lwait, this is ignored. Now we're going to run it by itself. And it's important that you set it to 1.
I thought we switched up.
I think
did.
you hit cancel instead of, okay.
Oh.
Yeah, I never said okay. I click over here.
So that's where you.
So now it's 0.003. You take this lwait out. And you substitute the 0.003 over here. And this is similar to what we do with the RTK and the OPUS factor. And now it's close to 1. Now you're not going to get this to 1 because you're only dealing with 3 decimal places. So that may be 0.0028 or whatever, but it's very close to 1 now. Now, I said there were 2 ways to do it. The other way to do it would be you don't use this lwait 1 here. You come over here to options, project.
We'll just change it.
And you change this to 1. If you change that to 1, it would work the same way. So you change that to 1. I don't remember if I clicked OK. Okay, 1 minute. Yes, I did. And then you would then put the lwait of 0.003 over here.
So if you do it this way, do you have to go back in those options and change that back to?
Yes, yes. So
when
the
you
lwait, I
process
think, is the
that?
better way to do it. the L-weight one is a better way to do it, because if you, yeah, because you, and no, these options only carry over for this particular project,
Yeah,
but still, yeah,
yeah, when you process it all together,
yes. So,
If you change that elevation difference to 0.003 without the L weight on, is it the same effect as?
yes, it would, I think it would be actually, yeah. You know what, let's find that out.
Turn off your L weight.
Yeah, it's, it does the same thing. I prefer this because it's right in the file and you can see it. So it kind of documents it. And it doesn't kind of document, it does document it. And so now we go back into project. Now it goes back to a 3D adjustment. And I'm just going to set this to the. So now we're using this factor. And now when we run everything, leveling residuals. Here we go. Now they're all back in line with what they were before. So now if anybody goes through and then actually there's my, now it's back up to closer to 1. Closer to 1 right there. So that it's given its proper weight. Yeah, and they're back in line with what you would expect from the leveling. So if anybody would now come try to follow you. Oops. And level from 101 to 102, they're going to get the same numbers as you did, rather than one that's off by, you know, then you adjusted more than it should have been adjusted.
So for this entire adjustment, we're not holding any one constraint, right?
No, we're not.
Okay, because that's not how it seems. We've done some of the smaller stuff, right?
yeah, we're just putting like all the weight on one, right?
Pick your favorite and hope it holds the best.
Yes.
And so are we gonna, there's still uses for that, right? I assume, unlike,
Yeah, what I do, tying into construction control.
yeah, you have to, right? You
Yeah,
need
you
one
gotta-
good.
Well, you don't need one good one. We saw that yesterday with the ones and stuff.
Oh,
It is
But
more
once-
of a, you're trying to establish a.
Yeah. But once you've got something in place on the ground.
Yeah.
Those points now, they're being used, this is being done for river sections. So those pair points are now being held. They're fixed at this point. They're whatever it is, we've adjusted it to. But now we haven't really discussed how we handle these ties to the benchmark. This is whole datum is once again tied to the OPUS RS here and the OPUS RS here.
Yeah. I do have a question about the listing file real quick.
Sure.
Can you go to the bottom of the listing file, like the second to last section? I forget what it is, but it's up. Yeah, the relative area ellipses.
Okay,
Isn't that the one that,
right there.
yeah.
Yeah,
So-
Jolly was putting a bunch of weight on that. I'm not really, he
Yeah,
kept
that's, so
showing me
that's,
that was, you know. you
that's
gotta look
Greg
at that
Bly's
stuff.
thing that he looks at is the station. I can't remember if it's a station, I think it's a station coordinate area ellipses. He wants everything under 200. What is your opinion on that for when we can't get him to pass that and we get to go argue with him to prove that 2200 is the same, or 22,000 is close enough?
She doesn't
You
need
think
to.
around to the, to the,
Whether
to the 100, I think,
25 or
'cause, like,
27.
Yeah, like I'm looking at like something that he would have like. And like, he would call us and ask why we didn't do something different. And like, our solution has always been if you just go into the options and change like your centering errors and stuff to get those numbers.
yeah, that's like the worst, that's
cheating.
statistical manipulation.
It is.
I know,
But like,
And I'm not gonna say I've never done it myself, but.
That's literally what he like, he'll call us and he'll be like, you're at like 27,000s here. Like, I think if you just say you centered it a little bit better, it'll go down, and you do it and it goes down and it doesn't change anything, but it's like,
You just punch the data.
yeah.
Yeah, and you know what, that's fudging the data. Like we talked about, these are statistics. This is, I don't know if you've ever heard the expression, there's lies, damn lies, and then there's statistics. You can make statistics say
Whatever.
almost anything you want. And I mean, I can't say don't do it, because I know I don't generally play with the centering errors. I don't, we had this discussion yesterday and you weren't in on it. But when I do GPS, I don't use centering errors. And the idea behind it is for RTK, you repeat at least twice.
Yeah.
So usually 3 times. For the static, every point is occupied, at least has 2 different independent occupations on it. So my take on that is that the centering error is based on the fact that you're going back there over and over again, and each setup is independent. It's just a little bit different. It's good, but it's a little bit different than the other. So that gets kind of built into the vector itself.
Yeah.
And I've had problems in the past. If I do long static sessions, my errors in those vectors are so small, sometimes the setup error is more than the error in this vector, and I can never get it to pass the chi-square test.
Right.
So after several very frustrating adjustment sessions, I came to the conclusion that I'm better off not using centering errors under the conditions that I have multiple occupations on that point for my GPS. I still use them for my traverse, because generally you're only setting up on a traverse point once.
Yeah.
Right.
So there, it does make some sense.
Yeah, this is more, I know they put a lot, like he puts all of his weight on this for when he wants.
Yeah, that's really misplaced.
Yeah. Which is probably why Jolly was putting so much weight on this,
Yeah.
because that's what we gotta deal with.
I mean, if you're dealing with a point where which is the hill you want to die on? That's probably not the hill you want to die on. Yeah, if he said, and especially if the regional surveyor or the county surveyor is saying just do this. I mean, he knows he's fudging the data too.
Yeah. Yeah, he's admitted to that on a phone call that we've had. Is like, yeah, he told us on Lake Road, because I had one that was at like, we had this whole fucking adjustment done and tweaked and twisted all this way, and we had one that was at 400s, and he made us tweak the data until it got below 300 so he could feel comfortable accepting it. Like, I'm looking at the coordinates and it's like not doing anything.
And
All
what
it's doing
was
is,
being
like,
done with this work? What was the work for?
PSMs.
Okay.
The PSMs that didn't tie into the other PSMs he had accepted for 2/10, and he knew that those ones were off 2/10, but ours couldn't be off by 400s.
Yeah.
So it was just like, yeah, it was one of those things where it was like,
He's our favorite.
yeah, but then like I'm going through and it's like affecting like the chi-squared, and I was like getting to where like that was basically failing. So then I like had to go back in and like tweak like the actual adjustment to get those error ellipses down. And I'm like, this just doesn't, like, it doesn't make sense to be so focused on this. Like, I feel like that's just creating a worse coordinate for the PSM.
And you're right. You're manipulating your data in order to get an artificial result.
Right.
I mean, like we said before, in my QCing, I was never able to get this. So the ones that I crossed out were the ones that were eventually removed. I take those out.
Yeah.
Gets better, but it still doesn't pass.
Right, it gets better, but it doesn't pass. What I ended up doing, now, what's the difference between 20 parts per million and 27 parts per million in an 885 foot baseline?
Couple thousands.
if that much, okay? What I ended up doing in my adjustment, right, StarNet gives you the option to do the testing. So I have 2 centimeters, which is 66,000, and 20 parts per million. And they have over here. So to 2 centimeters and 20 parts. Every one of those, if this number is greater than 1, I failed. And every one of them passed. So I could say with full confidence, even though I couldn't repeat my baselines to the 20 parts per million, I'm gonna say, okay, because I also added my total station observations in there, I am legitimately passing second order class 1. I'm allowed 800s. I got, I got 15,000s.
Yeah.
Or 800, yeah.
That wasn't just a pass.
Everyone
that's
is
like a
passed.
Significant pass. I think it's a
So your
station.
situation, are they all GPS observations? Do you have total station data?
In ours?
Yeah.
Ours was a traverse with statics, with the level run. I mean, it was the whole 9 yards and like, I think it's the station coordinate on, right? Not the relative, right? Where this is.
Relative.
Okay, I can't remember which one, but yeah, it was like, I had to throw out some data that I thought was good because I couldn't get it past that. And like, we had to put less weight on our traverse, which like, we're running a traverse with a 2-man gun with like, what I feel is our best field crew at running traverses. Like Stephen Down can turn a set of angles with that 2-man gun. And like, I was literally basically throwing out like some angles that they had because it wouldn't pass that. And it just,
That's the worst kind of data manipulation, but.
yeah.
And remember we talked about with the OPUS RS and RTK combination, one of the disadvantages is that some people are not going to understand it. They're just not going to accept it because, well, I've never done it that way before.
Right. And we were holding like PSMs that were shot in a topo from way back whenever, or like, and like forcing angles to close between them. Like, it was a weird situation. So I didn't like it, but I didn't understand it enough. So that's why I was kind of curious. I was like, I don't think this is right, but you say do it, so we'll do it.
Even when you do understand it, and you depends upon who you're dealing with.
Yeah.
So I mean, I understand this stuff pretty well, but I'll get pushback from the regional surveyor in New York City, and he'll say, "No, I want it done this way." And how much do I want to alienate him?
Right.
And then B, I've got 2 months left before I retire.
So now you can alienate him.
No, because I got to think in terms of this. When I'm emailing him back, at the bottom of that it says GDP, so it's
Right.
Christine and Jay. So sometimes you got to bite your tongue. And I mean, if he asked me to do something that's wrong, it's one thing. And I've got an instance I did and we're going to actually use this example later on as an example for processing. It's two azimuth pairs, and I was going to use the spec says you have to have the survey manual, the standards and procedures manual for the survey for NISA says that the company has to have 4 GPS receivers. You have to possess 4 GPS receivers. How they come up with that, I don't know. But when you do your survey, you have to use at least 2. And because of our workload, I only wanted to use 3. And I would then have to move receivers, but the work would be done correctly. They insisted, no, it's simpler if you use 4 receivers, just leave them on the 4 stations and do 2 sessions. So based on the specs for doing azimuth pairs, that would give me just the minimal amount of stations I needed. So if I were to do something like this. So I had a pair here and a pair here. So 1, 2, 3, 4. Okay, the specs for azimuth pairs say you have to have 2 vectors between them. So those are required. And then, like that. If I ran 4 receivers, I could get, for 2 sessions, I can get 6 baselines. I would get this exact minimum amount of baselines, 1, 2, 3, 4, 5, 6. So the first session would be something like this. Second session would be something like this. And then the first session would be this. And the second session would be this. So I'd end up with this. That's the exact minimum that you need in order to meet the spec for an azimuth path. So if anything went wrong, I'd have to go back out. So I told him, okay, I didn't want to fight with him about the 4 baselines. I could fight with him about that, but I told him that gives me, what you're telling me to do gives me the exact minimum amount I want to do. I said, I'll do the 4, like you say, but I'm throwing in an extra session because I don't want to go back out if there's a problem. He gave me permission to throw in an extra session, which I bit my tongue because anyway, I don't need his permission to do an extra session. Well, when I ended up processing it, I had a bad baseline. And so the way, if you did it with 3 sessions with the ties to the cords, there would be 18 baselines. I had a bad session. I said, okay, big deal. That's why I threw in an extra session. I could have got it to work probably, but I didn't need to. Why spend the time making something work that I don't need? I turned it in with 17 baselines instead of the minimum that they wanted me to do. They came back in their comments, you said you were going to do 18, you only did 17. At that point, I had to push back because you told me I only had to do 12. I've got 17. Why is 17 worse than 12 that you wanted me to do? And I haven't gotten, I haven't got the response back yet. But that's the kind of things you got to deal with.
Problem with Greg Bly, the local county surveyor, is there's no one to challenge him except other local surveyors. And in order for most of the stuff to get passed, it's whatever he says and whatever he wants in order for things to get through. And he seems to be the kind of person that plays favorites.
Okay.
I've noticed that, he treats certain people differently than he does other people, which is part of, I don't know, Dave's frustration, because, I've dealt with this guy before on other projects.
I just had Chris call him. He loved Chris Lock.
Well, that's what I mean, is
he
it's,
just- I'd be like, Chris, this is what I did. Chris would review it, say like, okay. Call Greg and be like, this is what we did. And Greg would be like, all right. Well, like if Justin called him, no shot. Those two would not get anywhere, so.
Yeah, there's no mathematical solution to that.
No. It's just have Marty call him now.
So, so if there's no way you're gonna get paid unless you get that to work, I'm not gonna say don't do it, but I am gonna tell you that it's not statistically justified.
Well, for this particular job, there was no way anybody was getting paid because he was withholding payment for the contractor. So it was like $1 million waiting on the control report
Okay.
to be accepted by him. So yeah, we made it work because our $2,000 part of the job was holding up $1 million.
So yeah, you made it work.
Yeah.
That's nothing I could say,
Yeah. It didn't feel great, but
Yeah, that's not a least squares problem, that's something else.
and that's the same one where we had to go back out and shoot property control or property to make sure we were close enough.
Okay. Okay, so we have our ties to the, we still haven't really addressed this over here. So what we did here is we did end up doing a separate vertical adjustment. And here's what you see with the alias names. So T101R being remote, we had to, we couldn't directly occupy the NGS benchmark, so that's a R being remote. This one we were able, no, that's an R also. So this, the field crews put the PID numbers in, and I just converted it to the doing the alias. I don't have to do a search and replace to do that. These are our NGS benchmarks. So these are real elevations, leveling to those benchmarks. And actually, I did QC's at leveling over here. But it all was within the second order class 2. Actually much better than what it needed to be. And that's reflected over here, the number lower than 1. But these are just my ties to the external data. I'm not combining them with other data, so I didn't bother going back and changing,
Yeah.
you know, the weights to them. These are all my GPS and total station data. And I brought this out the same way we saw earlier. Okay, so these are the points I have, my GPS points and my leveling elevations. So this is my H, capital H is the symbol for northometric height, lowercase h is an ellipsoidal height. The difference between them is 500s, 400s, and 600s, or 700, in that range. And you can see, so by combining multiple OPUS RS, any one of them, it could be out a tenth or so. But when you put multiple ones together, in this case 7, I mean, we're all within a tenth. So if I don't really need to, if being within a tenth of datum is good, multiple OPUS RS, or multiple OPUS for that matter, combined is going to get you there. Now, for your own peace of mind, I generally try to do a tie into the base benchmarks. So here I could prove that my worst missing of a benchmark is 700s. I take the average of those two, and just like we did before, I apply that average, and in the case, you could give the cell a name, and I call it the bias over there. Every one of these elevations is this elevation plus the bias. Now my difference is, once I do that shift of the 54,000, I hit 2,000, 2,000s, 13,000s, 15,000s. And you can't level that well over those distances.
No.
So in this case, I did not care about my error factor for my leveling because I know it was not going to change.
Yeah.
To change my values. I didn't bother taking the time to read it. And so then my control file, I take these elevations and actually, well, it's this right here. I just copy and paste. And I paste the values. And that's my control. And so, yes, I have not hit my benchmark. I'm within, yeah, I didn't hold my benchmarks. I generally try not to hold benchmarks in an adjustment. I'm like in this case, they're all up to the north. Little differences can introduce a tilt in the adjustment. So I prefer to do that simple translation up and down. Now, I don't know how anybody could tell me missing by 15,000 is bad, but I'm sure I'm told that I should be holding the city surveyors has told me that I should be, holding certain things. In this same job, actually, I'm supposed to hold 3 cores. Well, one of the cores, if I hold the 3 cores, I don't pass the chi-square test and my elevations are changing by a 10. I got 2 cores that agree within a few hundredths. And then if I add that one, now all my elevations are different by a 10th than if I don't hold that one.
Right.
And I'm going to level through it. So holding the elevation on the cores actually does change the horizontal, but in the 4th decimal place.
Right.
So my argument is I'm going to level these anyway. What you're asking me to do is inconsequential. So let me do it my way.
Right.
Now, whether that's going to fly or not, I don't know. But I generally, unless, if these were well distributed, you know, one in each quadrant, and maybe I might hold them then, but generally, I just find it easier to move my traverse up and down to fit the benchmark. And I don't know, I'm repeating myself, but
Find that, on the construction side, if you're trying to localize a site and you hold too much on one side, it'll
yeah,
tilt the plane.
yeah. Yeah, if they were all, and yeah, and if they're all on one side, like this is, you can end up tilting the plane, or if they were all, yeah, if they were, yeah, you could end up tilting it.
Just don't ask Carlson about that. He'll argue with you till the day you fucking die.
I know. There's numbers even about how many you should hold. 3 and 5 are better numbers than 4 or 1.
3 is actually a very bad number.
Yeah.
3 is always gonna be 0.
Well, yeah, 3, yeah, because 3 points define a plane.
Yeah.
So yeah, you'll always be 0 with 3.
Yeah.
But if you use does Carlson allow you to do just the vertical translation without a tilt?
Yeah,
Okay, so you can see how they're
you
working.
can do either option, but
Yeah, machine control, doing those localizations and stuff, though, I run into it a lot where like the dealers go out and they do a 3-point localization for horizontal and vertical, so it's like, they're fucking garbage.
And they tell you, oh, it's perfect, see?
Yeah, you're vertical 0, what do you mean it's no good? Like, we ran into one, a couple of years ago, the top of the hill was, it was like 100-foot tall hill, and the top of the hill was a foot off if you were on a level up to it, from what the GPS said.
Okay, because they can use it as a tilt.
Yeah, they ran a plane on the bottom side, so on the bottom of the hill, because they didn't want to climb to the top when they localized, so localized hit zeros, get to the top of the hill, they're a foot off vertically. Yeah. Not everything was built when, by the time we got out there, because we were just doing some curb work, so it was kind of one of those, well, I guess this is what we're rolling with, but yeah.
Did you have to recontrol it in order to get that?
We recontrolled it for who we were working with
Okay.
to get through it, but I mean, it just, yeah, it was one of those things that like, then they went back out and added this other building in, and of course, then they had a way to get to the top of the hill, so they used that control to localize that building. They like went back to some of their original millimeter hubs, and it was like 8 to 10 inches off, and they were like, we're 8 to 10 inches off, and I was like, just pretend those don't exist and start over. So we got through it, but yeah, it was
One of
it was
those,
interesting.
yeah, make it work.
Yeah, I mean, we were coming in so late out, it was, there's nothing you can do, but like, you can't take something like that, build the whole site and expect it to be right, the flat plane. So we run into that quite often.
Okay, this is the last of my canned, adjustment type things. Are there any questions on anything we've done so far?
Tying the cores in horizontally. You were just talking about that, tying the core station.
Yes, actually, what I'm gonna do, I have planned the processing in GPS.
Okay.
So we're gonna import cores data. We'll show you how to do that. The adjustment is the same thing. You in essence, you try to hold the cores. You generally try to use 3 cores and you try to hold them. Yesterday, we looked at those short-term series. Sometimes you can, if you can't get it to pass, because the cores are good, but they're not perfect. You can use those values in your constraints, but otherwise it's the same. A cores is just it's just a control station. And we'll show you how to bring in that data.
Okay.
I've been talking for like 3 hours straight now.
Yeah.
Get some water.
Well, I have water, but I need to go to the bathroom. So we want to take a half-hour break, 15,
Yeah, sounds good.
well, we're gonna eat at 12, I think they're bringing food in.
Oh, nice.
Damn.
So,
One day.
let's take a 15-minute break.
Cool.
Okay.